Alright, I'm going to be moving on with adding CANOpen to this firmware. For now, I already have a CANOpen driver, which I've developed before. And what I'm going to be doing now is porting it to my new device tree, making sure that we have a clean implementation of the variable directory. I have a few ideas of how to do that. I think that my current implementation is a little bit messy because it basically sees every single address in the directory as a separate variable. I think it would be much more reasonable to have address ranges, where I would just register a range of addresses, so kind of like a registry map. But that's for later. Right now, just adding a basic functionality for CANOpen. And we're also going to be testing this because I have two CAN interfaces, so I can have a CANOpen master on one of them and CANOpen slave on the other one. Let's see. I'm going to add CANOpen here. And I'm going to move the CANOpen from libCANOpen to my lib driver. There's really no reason to have a library with just single C file. See. Shall I put it under CAN? Let's see, CAN. Yeah, come on. There we go. And I'm going to remove libCANOpen from compilation. Let's see. Oh, maybe I don't actually have it. I don't think I'm linking against it, am I? That will become apparent when I rebuild. And if I get any duplicate symbols, then I have two libraries that contain the same code. And also, I'll be simplifying this API because I have such a complex API with so many different functions, and this actually implements 402 profile directly in the driver, which is not really correct. It was a quick solution to the problem. So I'm going to probably implement the profile, the actual CANOpen profile is going to be implemented by a higher level driver. and instead of CANOpen init, it's going to be CANOpen probe. And all of this stuff is going to be configurable from the device tree. So no need to have any special methods for setting the time period for the sync, stuff like that. I'm going to move this to, let's see. This is going to go here. Oh, so many functions. And this will, yeah, and this will just, let's delete backwards until the matching parenthesis. D, big T, and parenthesis. Yay! Vim is great. Vim is an awesome editor. Like, I don't know any other editor that comes close to being so cleanly designed, and so, I don't know, how should I put it? So smart in how it's been designed. Especially the interface. Like, my main reason for using Vim is the interface. I love the interface. Absolutely great. It would be nice if other like even graphical IDEs would follow the same principle of kind of embedding an editor that has proper key bindings. That would be the best solution, I think. But until then, I'll just use Vim. So this will be, CAN port will be actually the, let's see. So the reason I'm doing this right now is to make this CANOpen code an isolated driver instance with as little, only with a public interface. So there's not going to be anything that's going to be accessible without, outside of this public interface, which is a good way to make sure that it's easy to design the code so that it's thread safe, completely thread safe. And the second reason is actually to be able to configure everything from the device tree instead of having to configure things manually. Now, I kind of started to port all of the code that I have to device tree because I think it's great, and then putting all the dependencies between drivers into the device tree, and any kind of static configuration that kind of like sets baud rates, things like that. That's just best done through the device tree. So moving on here, this will be let's see. And for the ops, this is for like the operations that get invoked when anything is being read or written to the variable directory. Ha, cool. I just love this. So, like, when you learn basic commands in Vim, you can actually sort of string them together to get more complicated commands. So, for example, what I did here was like, like there's like CIW, it deletes the word. I think it's like, what does C stand for? C? No. So it's C inside word. C, whatever C stands for. And then if I want to copy this word, then I can do yank inside word, and it copies that word. So I could do, or like I could do, for example, copy the text until the semicolon. So yank T and semicolon. So yank to semicolon. Ta-da! Awesome. So the vardir is not going to be here anymore. Let's see. Delete big T, comma. So this can be sync call ID. And I'm going to comment this out for now. So you see how the vardir, the way that vardir is implemented right now, is that I have to set settings for every single variable, which is a little bit messy. I would say maybe a little bit bloated actually. So I want to rewrite this so that I get a range of addresses to which I just assign a single handler for reading and writing any variables in that range. But I think I'm going to do that after I get the CANOpen working, or at least compiling and sort of getting it up and running. CANOpen probe, CANOpen remove. And in terms of the 402 profile, this should probably be implemented by the firmware. I can pretty much guarantee that I'm not going to be done with this in this video. This is going to be a lot of work. At least a couple of videos. So most of this public stuff is going to become static and going to be local to the driver. CANOpen H. Is there anything I need here? Probably gonna need a lot of this, except for the profile specific stuff. All right, let's do like this. Yeah, it's actually going in lib firmware, not lib driver. So I'm going to move this to lib firmware include CANOpen, or actually I'm going to copy it, and then I also need to add this to the make file so that it gets installed. And then the first thing that's going to go from here, obviously this, D2 there. I want to check something. This is a good video. Okay, let's see. Vim delete to including. So I know how to delete up until a character, but I want to delete up until a character and including that character. Oh, maybe Ah, cool. Ah, I see. So df. So delete forward and the slash. Awesome. And then replace that R and quotation mark. And I can just press dot to kind of duplicate the last macro. Duplicate the last operation. So basically, what Vim does is that it records a macro for the last operation, places it at the shortcut dot, and then it's easy to replicate the last operation. So now it's time to start cleaning this up. This is going to be, the first thing is going to move from here is going to be the implementation of the actual struct CANOpen. Because a lot of this stuff is completely irrelevant to any code that's outside of this driver. So I'm going to define this in the file itself. And now that I've deleted the struct CANOpen, all of this has to disappear as well. And this is going to be the firmware CANOpen. I have to include the libfdt as well. It's very easy to add device tree support using libfdt. I've modified my libfdt a little bit to add this extra methods that make things even simpler. So what if I were to rename or like re-implement this vardir as a regmap instead, and have every single entry in there as a 32-bit value. For CANOpen, it's important to know the size of the variable because that saves bandwidth and allows multiple variables to be packed as part of the same CAN message. So any implementation of vardir like any other implementation, maybe I would call it like Readmap. It needs to provide a hint of the actual size of the register which is used. So like if the register if the value can be expressed as a uint8, then that's very good because then we can pack 8 values into a single CAN packet. So that's something to consider. But also I don't want to spend too much time, I don't want to make too many changes that don't really add any value. If I make any changes, it's going to be something that simplifies things a lot. So I want to avoid adding any changes that aren't worth the time, I guess. I want to keep the names short for the threads. Yeah, and then implementing this CANOpen. Should I have a separate device class for CANOpen? I have to think about that. All of this needs to be handled as well. So if there are PDOs that are mapped, we send them out here. And the way that CANOpen driver works is that it uses this a reference to a vardir from which it gets the PDOs that have been mapped. So it doesn't actually know. It doesn't need to know where the variables that it accesses are located. It just uses the same variable directory with which other drivers have registered their variables. And when it calls this get uint32, if this is a dynamic field, then a driver-specific method is going to be called in order to read that data. You know what I think? I think it would be nice to just return the size of that variable. In this case, it doesn't really matter because I just get the uint32. So let's see, vardir read. Better to use size of value instead of 4. I prefer not to hard code things. So vardir get index value size. Okay. It should compile. Yep. 6 arguments. I'm not going to provide any name. And also that thing with names, I don't like that. I think I'm going to remove that completely and just if I rewrite vardir into like Readmap or something, then I can just assume that every register is just a 32-bit value with possibly with some specifier that specifies if the value can be expressed as an 8-bit integer. Actually, I would have to have that because for can I want to have that. But beyond that, no names, not in the variable directory. Names can be implemented then later on top, sort of kind of like mapping different names to the addresses in the registry map, and then those values can be set from console. But that would kind of be like that would be a separate driver that implements just that part, just the mapping between local registry map and string values, or like string names for the variables. Vardir get undeclared. So why is it undeclared? Yeah, lib firmware should be built before. Let's see, maybe this is something. That's not right. Let's see. Oh. Right, I think some of the text is just missing from the output. So the way the new Vim works is that it doesn't actually output everything when running a command, but in the quick fix I can see all of the text. But why is this not defined? Var dir get? Okay. Let's check the staging there. Var dir get? This is very weird. Am I missing something? Like, am I staring at this and missing something? I should have the file included. Okay, I see. So it says undeclared because it requires 6 arguments. Okay. Let's see what arguments we need. We need to specify the size. and I'm not going to check if the value does not exist here. Or should I? The problem here is that this is going to be called a lot of times. This is going to be called like once every millisecond. So if some device configures or like misconfigures this node to read some value that does not exist, we don't want to have console messages coming out every millisecond. So that's why I think it doesn't really make sense to check for the error there, because I would have to log it anyway somehow. So I'll just output 0 if the value does not exist. And this is for reception. So this is setting the index name null and setting it from var uint 32. I'm gonna simplify this. So this is just bloated. This is so bloated. There's no need to do that. And even here, like testing for errors is not appropriate. The only thing I could possibly do is maybe log the number of failed attempts. But just even logging the PDO that's being written is not feasible. Passing argument 5. Okay. Now I just write it like this. Yeah, This doesn't really matter, so I can just go like this. And this border entry. So this code gets called when we do an SDO read from the device. So the way I've implemented this is to get the entry by ID, which not really. I should just call like get, and then return have the get return the number of bytes, the size of the entry. And the type here specifies what type I want to get the entry as. So if I specify uint32, then I want to get it as uint32. So if the value is a string stored in the varchar, then the varchar should return an int32. This is going to get a little messy. I'm gonna have to move all of the unit tests as well and update them. Let's see. That's an interesting topic in and of itself. Unit testing device drivers through public interfaces, possibly even on the actual hardware. That's actually an interesting idea. Having unit test that runs on the target. The amount of bloat in this code is incredible. I really don't like this implementation now. I just want to get something working before starting to refactor it. Why does it say? What the hell? Oh, it was there, okay. This one goes away. I need to fix this as well. This is just so ugly. There's nothing ugly in this. Okay, there is a lot of things that are ugly in this. This is still ugly. Okay, I'm gonna have to stop this video pretty soon. So if it works, great. If it doesn't, then I'm gonna continue in the next video. Var there. What's the declaration of get u16? So I'm going to cast the pointer here and then set the memory location to which it's pointing. And it's going to be set to val here. And then here I will cast it to int16 and set it, yeah, essentially just casting it to the right type. And that will take care of any clamping of the value as well. Int 8. And actually, yeah, I think I need to also do this, because otherwise GCC will complain. I'm trying to convert 32-bit integer into 16-bit or 8-bit integer. Undefined reference to can listener init. Let's see if this works. Can listener does not have handler. Process message. Right, and also list. So init list head. I always forget. Is it like, should I use init list head or list head init? It's two different macros depending on whether the list is a defined variable, like a global variable, or if I'm actually initializing a list. Maybe that's not necessary, actually. because the CAN device is always going to be passed to whoever is registering the listener. Come on. No. And the message there. God damn it. Come on. Can device. Okay, can listener in it. Why is it incompatible? This is supposed to be a CAN device. Oh, damn it. Fuck. When doing that, it's actually, it opens the file in the staging div instead of opening the file in which is in the source directory. So I have to do like this. Listener init. Okay, I'm just gonna do this quickly. Come on. Listener init. Or actually no. Past that. All right, and it crashed. Anyway, so somewhere in the CANOpen initialization it crashes, and probably I forgot to set some pointer. But I'm gonna fix that in the next video, hopefully. So that's it for this video, and until next time.